continue with the next presentation. Aydın, Mr. Aydın DEMI.
Yes, can you hear me?
Yes, I hear you. Welcome.
Okay,
you can continue, please.
Let me start. Okay. Good afternoon, everybody. My topic is the effects of sanding and various surface smoothing processes on surface roughness and varnish adhesion of beech, oak, and pine massive parquets. The primary function of any wood finish, paint, varnish, wax, stain, all etc. is to protect the wood surface and maintain a certain appearance and provide a cleanable surface. Finishing of wood material is one of the most important processes influencing overall quality of the final product. Physical characteristics, in particular appearance of the finished product, are affected by not only the type of finish but also the interaction between finish and the substrate. It is a well-known fact that spaces, wood density, and roughness of the substrate are considered major parameters to have an effective finishing process. Wood coatings prolong service life by safeguarding the substrate from, in particular, outer conditions like UV light, high and or changing humidity, mechanical damage, chemicals, living organisms like fungi, termites, etc. Coatings can also further improve aesthetics by providing color or gloss. Surface preparation is the most important factor in developing a successful coating system. The purpose of surface preparation is to remove all contaminants that can interfere with adhesion. Sanding or mechanical cleaning is then required to remove loose or deteriorated surface on wood to obtain proper surface profile. The process of abrasive sanding is essential in the manufacture of value-added wooden furniture which demands quality surface finish. Some mechanical treatments such as sanding and planing can be applied to get a fresh surface which eliminates bonding problems and improves glue bonding of wood. What is your aim? The objective of this work was to determine effects of sanding and various surface smoothing processes on surface roughness and varnish adhesion of beech, oak, and pine massive parquets. Materials and methods: beech, pine, and oak massive parquets with the dimensions 5 cm. 1.8 cm were obtained from a commercial parquet located in Karadeniz region in Turkey. Parquet sample manufactured from beech, pine, and oak wood were classified into 4 groups. 15 parquet samples were used for each group. First group were processed on thickness machine. Second group were processed on plane machine. Third group were sanded with 60 degree sandpaper parallel the grain direction. Fourth group were sanded with 180 degree sandpaper parallel to grain direction. Surface roughness values of parquets were determined after planing and sanding processes. Metotoyo surface test SG301 was employed for surface roughness measurement. The roughness parameters average roughness, mean peak to valley height, and maximum roughness were used to evaluate surface roughness of the sample according to DAN 4768. After surface roughness measurements, parquet samples were coated with cellulosic varnish by using a spray gun at the spray rate on 120. The coating was applied to surface as two bases and one top layer. The mixture of cellulosic varnish for each layer had a 100 parts varnish and a 550 parts thinner by volume. Once parquet samples were dried in ambient temperature after coating process, dry film thickness H samples were measured by using Ericsson PAG 44.5 measuring device at an accuracy of 1 micrometer according to ESTM D4138. Average dry film thickness of cellulosic varnish was measured at 80 micrometer. Pull-off test was used to evaluate addition of strength of the parquets and samples according to ESTM D4541. 15 replicate measurements with a contact area of 20 millimeters circles were taken from each side of the sample. Ericsson 525 MC adhesion tester with a heat of fluid the surface of the sample was employed for the test. Results, you can see it was shown in table that surface roughness the results of parquet samples after processing on thickness and plane meshing and sanding. You can see what parquets gave to the highest surface roughness mean values due to most porous anatomical structure having the roughest surface. The smoothest samples were obtained after sanding with 180 grit sandpaper for the parquet wood spaces, 60 grit sandpaper sanding the highest values obtained from. You can see a pull-off strength adhesion test result of parquet sample after processing on thickness and plane machine and sanding were presented in figure. Adhesion strength values of beach parquets with cellulosic varnish were found higher than this oak and pine parquets. The adhesion strength varnish on wood surface has been reported to higher in wood frame from angiosperm trees compared to gymnosperm. The smooth surface quality of beech may be responsible for this finding. The highest adhesion strength value were obtained for the grit sandpaper with 60 grit sandpaper. It has been reported increased surface roughness leads to increased varnish layer adhesion strength resistance due to a mechanical and chemical bond between the wood sample and varnish liquid when applied its surface. Conclusions: the high surface roughness values were obtained in oak, and there was no statistical difference between beech and pine. The adhesion strength values of beech parquets were higher than pine and oak parquets. Processing of sanding with lower grit sandpaper results in increased surface roughness with improved adhesion strength characteristic between in coating and the substrate. Therefore, it is recommended from this that where high varnish adhesion strength is required. The wood surface should be sanded with low number grid sandpaper. Thank you for listening.
Thank you, Aydın, for your nice presentation. I see that I'm looking at another questions. I see no questions. Thanks again, Mr. Aydın, for your nice presentation.